Welcome to the Deep Dive. Today we're venturing into the world of Digital Equipment Corporation, or DEC, and one of its most influential creations, the PDP-11 Unibus family.
That's right. These machines, they were pretty remarkable.
What made them stand out, really, was their flexibility. I mean, you could expand them, add memory, peripherals, without hitting major roadblocks.
Exactly. And the key to that, or a big part of it, was the Unibus. It was just this elegant design for letting components talk and letting the system grow. You didn't need a whole new architecture every time.
Okay.
And for this deep dive, we've got this fantastic resource, the PDP Unibus Processor Handbook. We're going to focus mostly on the PDP-1184, the 1144, and the 1124. See what made them tick.
Right. So our mission, if you will, is to dig into this handbook, pull out the really important stuff about these three models, like a shortcut maybe, to understanding their core strengths, their differences. Because while they shared the Unibus, they definitely weren't identical. Each had its own niche, right?
Absolutely. And it's interesting, the handbook itself was aimed at, well, two groups, really. People evaluating, trying to choose the right PDP-11, and also the engineers needing the nuts and bolts of the Unibus for, system design and interfacing.
So it's packed with technical detail.
Oh, yeah. A real treasure trove.
So let's start big picture then. The Unibus itself, what made it such a game changer? What was the core idea?
Well, what's fascinating is that it was a single pathway, a single bus, but communication flowed both ways, and crucially, it was asynchronous.
Asynchronous. Okay, what does that mean in practice?
It means instead of everything marching to a single clock beat, the components sort of politely waited for handshake signals. Are you ready?
Right.
Okay, here's the data. Got it. That kind of thing.
Okay, so not rigid timing, more like a conversation.
Exactly. Made it much more adaptable. You could hang slower devices off it alongside faster ones without everything grinding to a halt.
And this handbook details the 1184, 1144, 1124. So besides this common Unibus backbone, what else tied them together, made them a family?
Well, a lot of it was the underlying software architecture. The instruction set, the way they fundamentally worked, they spoke a similar language, you could say, so software development had some consistency.
Right.
But, as we'll see, each one did bring its own capabilities. Sometimes subtle differences in, say, memory management could really change what applications they excelled at.
Okay, let's get into that nitty-gritty, starting with the PDP-1184. What were the headlines for this machine? What made it stand out?
The 1184 was a real performance step up. You see DEC starting to build in features we now take for granted, like caches.
Caches, right, to speed things up.
Exactly. It had a high-speed DMA cache that helped speed up transfers from things like disks, and also an 8 GB CPU cache for program instructions and data.
So faster I/O and faster program execution.
Yeah, and it could even do CPU processing and Unibus I/O concurrently at the same time. Made things much more efficient. Plus, programmable bus mastership. Basically letting the CPU prioritize its own path to memory.
It's pretty sophisticated for the time.
Yeah.
What about memory handling, processing power?
It could handle up to 4 megabytes of ECC MOS memory. We should definitely talk about ECC later, error correction code.
Okay.
And it had an integral floating point processor built right in.
A math coprocessor, essentially.
Pretty much great for scientific stuff, engineering apps, anything heavy on complex calculations. Its memory management unit, the MMU, was also quite advanced. Dual register sets, 22-bit addressing.
22-bit, so more memory addressable than earlier models.
Right, and separate spaces for instructions and data I and D space, plus those 3 operating modes: kernel, supervisor, and user.
Those modes sound important. What was the idea there? Why separate them?
Well, it really gets at system security and control. Kernel mode was the king. Complete control, total privilege.
Okay.
Supervisor and user modes, though, they were restricted. Certain instructions wouldn't work. Couldn't directly poke at peripherals.
So it wasn't just user accounts, it was hardware level protection.
Exactly. A fundamental architectural choice to stop user programs accidentally, or, not accidentally, crashing the whole system. A big issue on earlier machines.
So the kernel acts like a guardian.
You got it. The handbook also mentions other standard bits. A console serial line unit for basic comms, control over the line frequency clock, optional battery backup.
For power glitches.
Yeah, short ones, keep the memory alive briefly. And a standard 32 KB ROM for bootstrap and diagnostics.
You mentioned a J11 chipset inside the CPU.
Yes, the J11. That was basically the brain of the 1184. It implemented the instruction set of the bigger PDP-1170, including those floating point instructions and the memory management we just talked about.
Like hacking a lot onto silicon.
Very much so. It was actually 2 main chips, a data chip handling the math, logic, data movement, timing, and a control chip using microcode.